a smarter city system, or writes a lot about it. No, you've built stuff too. Yeah.
Theoretically.
Hence the guru. Yes. So this is going to be a lot of fun, and what I figured I would have them do is each of them is going to introduce themselves, and then we're going to go after that, and they're going to tell a story or tell about a time, like their lessons learned in implementing or building or doing some kind of system. So you guys should totally listen up, because I have learned many things, and quite frankly, I'm scared. So we'll get started with Javier. Would you like to introduce yourself?
Yes, good morning to everyone. My name is Javier Martinez, and I'm the Chief of Business Development at Libelium.
And Libelium is?
Libelium is a wireless sensor network company, technology company based in Spain.
My name is Kuniavsky, and I guess I'm wearing two hats here. One is that I'm in the Innovation Services group at PARC, where what we do is we essentially reduce the risk of our clients adopting novel technologies, and through a variety of ways. And I've also co-founded Thingum, which is essentially an Internet of Things startup, and we've been making products for like 6 years, something like that.
Cool. I'm Scott Miller, CEO and founder of Dragon Innovation, and we help companies go from the prototype to high volume manufacturing, and also have a cool hardware-focused crowdfunding site.
And I'm Peter Semmelhack. I'm the founder and CEO of a company called Bug Labs. We got started in the open source hardware space and sort of evolved now into what's now called the Internet of Things. We have software and hardware that helps people innovate and bring new products to market.
All right, let's get started. We're going to go right down the line with Javier. Let's start with your pitfall, your horror story.
Well, one thing is we found that implementing or deploying an Internet of Things or end-to-end solution, that one thing is conceiving this solution, one thing is conceiving this this business case, presenting it, and actually selling it, and a totally different thing is the actual deployment. For example, we deployed a wireless sensor network in a city in Spain for a smart city initiative, and we found out that although the technological proposal was horizontal, it was meant to be giving a response to a global initiative for the city, we actually found that the city itself, the municipality, was not aligned with this horizontal approach. That is, we were implementing 4 different solutions based on our technology, which was involving different departments within the city, within the municipality. And what we found out is that there hadn't been a communication between them. There hadn't been the right communication between departments. And we were finding obstacles when installing and deploying the equipment. For example, the mobility department, there was a parking solution, a smart parking solution. The mobility department had not warned the lighting department that we need to install our equipment on lighting poles. So we got this right obstacle to as I say, to install the equipment and to get the solution running.
So make sure that when you sell something that everybody's on board, and all of the different, especially in smart cities, everybody knows that you're coming to install things.
There's nothing, I mean, there's no sense in having the right technology, the right technological approach, a horizontal approach, if there's not such an alignment with the end user.
So I think I've got an example from kind of either one of my hats. But at PARC, we develop a lot of really very, very new technologies, and the giant challenge is explaining the value of those technologies. So it's one thing to develop a technology, it's another thing to essentially create a kind of a commercial explanation for what the value of the technology is. I'm sure everyone has experienced this, but one specific case for us is that we developed these printed electronics technologies. So we essentially print, we can print displays and sensors and logic and batteries onto a thin substrate. And how do you explain that as a commercial product when it's just really like very much a very powerful but fundamental technology? So what we did there is we essentially said we're going to find a partner that's interested and has an adjacent business, and then we're going to work with them. And that partner was Thin Film, which is a Norwegian company, and they're developing a whole range of technologies around, or a whole range of products around these technologies. And they're essentially educating the marketplace, essentially on our behalf, about what the potentials are.
It's super cool. It's like you can put these for like cents, and they stick them on like cereal boxes, and the cereal box knows where it is.
Right.
And you know where it is.
It's kind of like, in many ways, like the next generation of RFID, but in an entirely non-silicon way. So you avoid kind of the entire silicon process and create something that's flexible and small and functional, very global.
So your lesson there is find a partner who can help explain, kind of.
Yeah, exactly. And
kind of like I just did there.
So it's a similar thing in terms of explaining the value of augmented objects. So one of the things in the Internet of Things you get a lot of is you get this problem where you have an augmented version of something, a connected version of something that's versus a non-augmented and connected version of that. And the challenge there is that when consumers look at it, they go, oh, why should I pay like 4 or 5 times as much? And equally as importantly, do all this extra work. Like, I never had an app for my smoke alarm before, but now I have this other thing that I have to manage, I have to think about. And so why should I do that? And you know, the way that Nest is doing it, but a number of other people, we things are doing it, is they're doing it through design, but they're also doing it through user experience design as well as industrial design. But they're also doing it by really creating incredibly clear use cases for that.
All right, so product design, actual products, getting people to buy them. Before you can do any of that, Scott, what do you have to think about?
All right, so in the spirit of Halloween, I've got a manufacturing horror story, which pretty much ended our stay at iRobot. So before starting Dragon 6 years ago, I spent a great 10 years at iRobot. And like a lot of our clients, we were really focused on just getting the first thing built. We had really tight schedules, expectations from the press and so on, that we just needed to launch the product. And really didn't think too much about quality. We thought it was kind of important, but we figured out later.
Wait, you should tell people what iRobot, for the people who don't know.
Yeah, sorry. So iRobot is a consumer electronic company that builds the Roomba. So it's a really cool vacuuming robot that'll clean your floor for you, so you don't have to. And it's a highly integrated 5-degree of freedom electromechanical device. So for a robot guy, it's like, it's heaven. It's just really tightly put together. So we've been scrambling to get this thing put together and meet the schedules. And at the time, I was based over in China and get a call on a Saturday afternoon saying, hey, Scott, 1% of the robots are failing after 40 hours. And this is like the worst thing you want to hear. If they all blow up instantly, that's awesome because you know you've got a problem. But these intermittent things like, step 1 is always discredit the tester. No, that's a bad idea. Don't do that. Like, all right, I'll take this seriously. So I get on the boat, go into the factory 3 hours away and sit down, and lo and behold, these robots, are failing after 40 hours. We have a whole floor of about 100 of them running around. And at the time, we had built up 50,000 of them for Home Depot, which, if you think of 50,000 robots, that would fill more than this room. Like, that's a lot of robots. And you really don't want to rework 50,000 robots. So what we did is built this code called the blue light special, where every time one of the components would fail, the blue light would go on. And just looking at a sea of 100 robots, all the blue lights were going on. It's like, oh, this is really, really not good, because that's tens of millions of dollars of product. So fortunately for us, after 4 long days of pretty much no sleep in hot China, we did come up with a software solution to solve the mechanical problem. It was a little switch which was bouncing too much, and we were able to fix the product and ship it. But the lesson we learned there is you got to take quality really, really, really seriously, and not deal with it as an after a byproduct, but design it in up front.
Have you already shipped all the 50,000 robots?
No, thank God. We hadn't done the final inspection. So we just, and if this one engineer at the factory didn't raise his hand, because it's a Saturday, he wants to go home, nobody wants to say, this might be a problem. We would have been, there were, returns would kill you.
Right.
It costs like 10 times as much to get a return.
So there's lots of lessons there. There's the be nice to your engineering staff.
Yeah, so this is more of a perception versus reality lesson, and it's for anybody who's looking to invest in the space, media, entrepreneurs. You know, one of the things that I hear fairly often is either this or some variant of this, which is, you know, I think the next Facebook is going to come out of the Internet of Things. And it's an easy thing to get seduced into thinking because, oh my God, we're going to have 20 trillion devices connected to the Internet. That's a giant number. We can write an application, 99 cents times 20 trillion. Big number. But the problem is that, so when you think about it, a lot of people don't recognize this this thing, which is the Internet of Things is not the Internet, right? So a guy like Mark Zuckerberg could come up with this really cool new application for social networking, and it could go viral very, very quickly because we all had on our desktops, for the most part, a Wintel device, right? So an architecture that was made popular over many, many years, an Intel chip, a Windows operating system, standard browser, standard communications stack over a standard, everything was standardized. So one idea could scale with zero friction. Now, let's say Scott and I came up with this great new idea for diabetics that would really help them live a better life. And we knew we could sell this to lots of diabetics. But the problem is that there's no there. I can't use your iPhone or an Android device because there's no glucometer on that thing. So what has to happen in the Internet of Things is the things have to go first. You have to get them into the market, and then you can scale, right? And so therein lies both the challenge and the opportunity because you have to manufacture it, you have to get it out, it has to be successful, then you scale. And a lot of people don't recognize that the thing part of the Internet of Things phrase is the complicated piece. You've all heard hardware is hard, that's because it's true. And I feel like you serve yourself well by really digging into what does it actually take to get a thing into the market and then scale it because it's fairly sophisticated thinking. So.
And
yeah. Can I jump in?
Go for it.
I was actually going to redouble that and say that, like, as a software person going into hardware, so I was a software for a long time, you have this misperception that once you can compile something and get it to run once, that's awesome. You're done. You know, it works, and that's absolutely not the case with hardware, where not only do you have like a percentage of the atoms don't work like the rest of the atoms, right. But you also have this problem where when you make 100 of something versus 100,000, you have an entirely different set of processes, and so you have an entirely different set of thinking that has to happen around that, which is incredibly hard.
So to take this another step further, we want to get the things out there, and they're going to be built well. We've got to convince people of the value.
Yep.
And I'm not sure in my home if I can think of this, and that's where I'm going with the horizontal integration. But how do you create platforms, or do you create platforms? How do you create this ecosystem where I, as a consumer, can buy a glucose monitor and then later go buy a heart monitor and know they're all going to work together? Because that to me is the biggest stumbling block.
I think it's a huge problem because in that statement is a business model problem. Everybody wants to own the stack. So if you look at health as an example, you got Medtronics, you got Johnson & Johnson, you got all these guys who really are doing a great job in their particular vertical, whether it be diabetics or heart condition or what have you. But if you want those things to talk to one another, it's not going to happen because, again, everyone wants to get out of the thing business and they want to get into the services business. They want to give the thing away and charge you for services. And I think there's this inherent contradiction between what the internet did, because no one owns the internet, right? And what's going to happen in the IoT space, because everyone wants to own the IoT platform. And so one of the things I like to say is that before we had the internet, we had the information superhighway. We all know how that worked out. So how a platform comes to market where everybody benefits is a real interesting question.
What do you guys?
We found from our experiences, so first of all, to a couple of ideas. First of all is that end user, whatever the end user is, an individual, a municipality, a business, wants zero complexity. I mean, Internet of Things and the value chain within it, it's a long, it's a large thing. It's a very comprehensive and complex. It can be a complex thing. So, but the end user is not looking for that. It's looking for zero complexity. I want the solution, and I want the solution implemented and satisfying my needs. So, there is a need for all the agents involved, all the players involved, to find their space, to find their specific role. In our case, we're not aimed to jump in this phenomenal platform with an Apple one. We're focused. We're specialized on that small part of the value chain. And another idea is that we cannot trim a value chain. A value chain has to have all the parts. I mean, if we all want to be focused on one part, that is the service part that is creating the largest revenues, and nobody's taking care of the parts before, nothing is going to be done. I mean, no solution can be created.
So then, how do those, who will have the power in that situation to set the pricing? So if you look at like the App Store model, Apple knew it wanted to get developers involved, so it gave them a 30% cut. But at the same time, it was dictating pricing to carriers and that sort of thing. So there is a very real, I guess it's an open, it's a blank slate. Who will have the power in these kind of relationships? Does it come from the hardware guys? Does it come from your brand name? I don't know. Design?
Well, I think if you look at Apple, Apple did something interesting. When the iPhone first came out, if you remember, there was no developer platform at all. And so they did this great job, as Apple has now proven they can do multiple times, which is they sold a beautifully designed piece of hardware. It wasn't even that great of a phone, but it had this vision around it, just this awesome new thing, right? They sold millions in the first year or so, and then they turned around and they said, oh, by the way, developers of the world, do you want to sell apps to these 2 million users? And by the way, well, 99 cents is what we suggest. And so again, you do the math, 2 million, 99 cents, hey, that's real money. So the developers came in, right? So they were able to sort of start the fire. They sold the hardware. It was an existing device that people understood the value of. It's a phone, and then they created this ecosystem. So they sort of launched into this this situation where they did have a lot of power because they said they had users. And that goes to my problem I mentioned earlier, which is you have to get the hardware in place. You have to get something in place to get the developers interested, and that's just a challenge. And so.
I think that Apple's more the exception than the rule. I mean, everybody tries to make a vertically integrated ecosystem that they kind of own, and they create this environment. And really very few people have any success at it. Like essentially every consumer electronics company has their own version of this, but really Apple's is the only one that's really genuinely successful. I mean, I think that to me, the thing that is that's missing is that it's not about kind of being the Google of something. It's about creating the HTTP of something. You know, that's kind of the layer at which like that's, if you're talking about power, like I think the real power is like in the IETF. That's who really, not here, but in terms of like who like really enabled the web. And I think that's kind of the layer here, is like who creates the service discovery layer and makes it so open that there's the incentive for people to create business models inside it.
Okay, we're probably not going to solve this today. So let's move to this next issue, which is a big one, and I don't think we've really talked about it yet. It's about privacy and security when we start connecting things. So in a city situation, I'm sure there are all kinds of issues, ranging from surveillance to even someone hacking your parking system. So most benignly, you would never pay to park again, or skimming credit cards. I don't know what you could do. So
I think the issue within the city is, I mean, the city is a generator of huge data. Each day, cities generate huge data. And the issue is how do we approach this data? Do we have all the data open? And the data is from multiple natures and multiple characteristics, and involves different types of individuals and organizations. So we're for openness, but where is that frontier? Where should openness finish, and what kind of data should be open?
So we always go back. I love the saying from Paul Graham: "Build something people want." And for us, we're always balancing the value you get from exposing your data to the cost of, or the security of giving that up. And if it does something useful, then folks may be more likely to say, "Sure, I'll share that." But it can easily go the other way if that trust is violated.
yeah, I think actually we should probably make this distinction. Shame on me for not making it privacy versus security, because they're two different things. Like if I'm looking at open data, I do not want the red light cams to like I don't want those pictures taken of me, not that I'm running red lights. But I wouldn't want those available. It'd be like the mug shots online, right? It's just not something you want. So that's a privacy issue versus security, which would be like hacking into the red light cameras to really ruin my day and give me a ticket because I've alienated something somewhere who's very smart. So I guess there's probably different considerations here, but like Scott, for example, how do you build hardware that kind of takes that into consideration? I'll ask you how to build services that kind of take those things into consideration.
Yeah, I mean, it's an incredibly hard thing. I don't think we've found the right. I think it's still very much in play, an open question.
You're like, I don't know.
I can tell you, like one of our customers is Ford, and you've seen a lot of interest now in telematics and getting cars online. And there's a lot of interest in sort of things you can do, and I do agree there's lots of potential things from safety to efficiency to entertainment and so on. But the problem that the car industry has is this idea of driver distraction, right? So the big problem that Ford and every OEM in this country has is that, you know, God forbid, they come out with some really cool new open platform, somebody writes an application, someone dies. Like this is what keeps them up at night. And so it's you know, how do we build a system that doesn't open that? It's a cost-benefit analysis. There's huge amounts of benefit, but one thing will ruin it for everybody, and they're just, in many cases, not willing to take that step. Like OBD2, which is the interface, is totally locked down, and they're opening it tiny bits here and there, but it'll be very interesting to see how because they, in many ways, are under a lot of pressure to open it, and like Tesla is doing some interesting things.
Well, that's the tension between these open kind of versus these siloed systems. It's not just a business model thing, it's kind of an insurance and security. Okay. And let's kind of go forward to thinking about for businesses, because you know we focus a lot on consumers and cool things you can do with this, but businesses having access to this data, how do you think they will buy into the Internet of Things? Is it something like GE's platform where they're like, I have all this data, I'll give this to you? Do you think it's a little more ad hoc, or like who's going to win there?
I have a big opinion about this. So I personally think that the Internet of Things is going to take off in the enterprise way before it takes off in the consumer space. No offense to anybody doing smart home or anything like that, but literally for my entire career, home automation is always about to be huge. It's like, this is the year, home automation, you know, it's like artificial intelligence. It's not to say that all these things are happening, it's just for me, I think the problem with it is the ROI. Meaning, in business, you can say, I'm going to apply this really cool new technology, and I'm going to save you 20% a year, and therefore you're going to pay me this. Or I'm going to make you 50% more revenues, and you're going to pay me that. You can literally do that now, much easier with this type of technology. In the consumer space, it's a little harder. Like, what is the value of turning your lights on and off remotely? Even things like safety they're good. What's the real ROI? How much is it worth? Is it worth $300 or worth $99? I don't know. And so I do think there's huge amounts of opportunity. I think GE's got it right in the sense that the industrial internet, that's just my opinion. And I feel like in this, a lot of innovation going on in that space, I think we'll see a lot of interesting things happening.
I mean, my perception is that it's going to happen kind of in two ways. I think what the industrial internet is essentially people taking existing networks of devices they already have, like trucks or turbines or meters, and turning that existing network that's currently physically managed into a digitally managed and digitally understood network, essentially merging the physical network with the digital network. And I think that's much easier to roll out on a business scale when you have a physical network of things, whether it's delivery trucks or something like that, or washing machines or whatever. The other way that I think that it's happening is that businesses are starting to see that there is competitive value in creating a specific hardware device that generates a range of data that allows them to compete in terms of the service that they have against other services. And they're going to, and hardware, even though it's really hard, is actually comparatively easy relative to like all the business problems. You know, I think making a small sensor-based, battery-powered thing that connects to the net is actually somewhat easier than it is to create a successful business and a service. And I think services are going to be discovering that that's a competitive advantage, and they're going to be creating hardware to get people to lock into their services.
I agree with Peter in that the Internet of Things can take off before at a business level more than an individual's level. Because it's easier to, as I say, to build a business case and to present a potential return on investment. But in my opinion, eventually the individual's market will tell us like killer applications that can be developed. As we see that, for example, for businesses, we have not found, although our technology can be applied to multiple applications, we have not found a killer app yet. Still, we see it easier to present, to build these business cases. But I think eventually it will be the same at an individual's level.
So are you saying that enterprise kind of Internet of Things deployments are kind of one-off kind of consulting things versus consumer can be very scalable? Or am I just...
I think it can scale in both cases. It's just a matter of the potential end users saying, okay, this is going to be relevant for me. This is going to add value to my life. For example, an e-health platform, a remote health monitoring platform can be an example.
Right, but before that can have any value, it's got to have all these other things in it, and we have to actually all buy them so they can start building things for them that make sense for the developer. Gosh, we may never get there. How long till we actually have really viable, one-word answer? How long do you think until we have viable Internet of Things platform that we can point to and say, ooh, that's it right there?
10 years.
10 years.
I'll go for 5.
Yeah, 3 to 5.
3 to 5?
I would agree on 5.
All right. We'll see if Peter the pessimist is correct, or we'll all be excited in 5 more years. Thank you guys very much. I appreciate it. Give a round of applause.
Thank you, Stacey. Thank you, panel.